Okay. Yeah. So the relationship between the slopes of two perpendicular lines that we've seen in functions in one variable, linear functions in one variable, is just the part that the slopes, the product of the slopes, the is actually -1, right? So this is, can we relate this with that? Can we vary the a and b? And look at the what happens when we vary a and b. What happens to the also, is this true always?
If they are perpendicular, then definitely yes.
Yeah. For perpendiculars, we have this, right? Okay. So moving
See, if
on to the next.
no,
Yeah.
no, let us deliberate on one important thing here that you are mentioning about slopes. As you can see, x and y, a vector
Perpendicular
is
to each other.
no, not x and y. For example, there is a vector v such that x and y happens to be its coordinates. So the ratio of y upon x is the slope of that vector, isn't it?
Yeah.
So if you see in these two u and v vectors, always if you calculate the ratio y upon x and the ratio of v, that is y upon x again, it will turn out to be -1. It is varying
Yeah.
such that it always remains -1. That
Right.
ratio of those two
Ratio.
vectors.
Yeah. Right.
Yeah. So that is an observation we must make.
Right. What
It's
happens to slope for 1 comma 0 and 0 comma 1? Okay, good question. Can we just look at the graph once again? 1 comma 0. Let's take it to 1 comma 0. B. 1 comma 0.
Sorry, am I doing it
Can
wrong?
we, yeah. Can you see, Chituraja, what happens at 1 comma 0 and 0 comma 1? Is slope 0? Is the slope 0? What does that mean when you say the slope is 0?
X stays constant.
Slope you take with reference to the x axis, right? So the slope of u vector is 0. That is right. V vector is not 0. The angle between the two is not 0.
No,
So I don't.
sorry, it's the other way around, right? U vector is undefined and V is zero.
Hey, we are looking
V
at
is
a
No,
undefined.
sorry, yeah, the other way, yeah.
what
also
Chitturaja is
dy
suggesting
by
is that
dx. So
no,
dx
what Chitturaja is suggesting is that in this case the product of slopes does not turn out to be -1. So this is a clear case of where the slope is kind of undefined. So this is an
Yeah.
exception. So
Right.
yeah, we are not generalizing it. That's
Yeah.
so in the
That's
other than the exceptions, this is the case,
right.
and we I don't know we should call it exception or what, because it
Yeah,
is
y
not
by
defined.
x
It
is
is
not
something.
defined.
No,
Yeah,
what
y
about
by x is not defined when x equal to 0, right? So
Yeah.
so
So
actually denominator cannot be 0. So that is the thing.
that
Anyways,
that part is only applicable when your slopes are well defined. Only when your
ah,
slopes are well defined, the product is -1. If they are not well defined, we cannot say that.
yep.
if we convert this vector as a unit vector, then dot product itself will give us, we can just directly give dot product and check that directly.
Yeah, right. So the
And
dot product is the measure of alignment between the two vectors. It tells us how aligned those two vectors are.
But even if they are not unit vector, if we take a dot product between them and that turns out to be 0, then that just signifies that they are perpendicular directly.
Yep.
Okay, can you say when slope is well defined? Message from the chat.
When the okay, so is this tan theta, right? So tan theta, when theta is 90 degree, tan 90 is not defined. Okay. If your tan 90 is not defined, your slope is not defined for that particular vector. Okay. That's it.
Actually, this has got very little to do with, linear algebra. This is a very old coordinate geometry concept.
Yeah, exactly.
We were
That's
just
why I
kind
brought
of
it up.
we are just kind of revising it,
Yeah, but just revising it. Okay,
Brushing
moving
up
on to
it.
the next question. So the next question says that what is x comma y comma z satisfying the following? Use GeoGebra. X, Y, Z, one multiplied with the column vector 1, comma 2, comma 3, and gives us 0, comma 0, comma 0. So for this, we'll need a 3D calculator. Let me put a link to the 3D calculator in the chat box.
Now the importance of slope will show up,
Yep. Dot product will show up. The importance of dot product.
Yep. I meant to say, we must appreciate the importance of new thing that we are going to learn.
Yeah.
Else, otherwise we were just calculating m1, m2 is equal to -1 so far. Anyways, let us see what happens.
So one vector that we have is x comma y comma z. Another one is our 1 comma 2 comma 3, and the output should be 0 comma 0. So that is we need a perpendicular vector to 1 comma 2 comma 3. Another vector x comma y comma z will vary this vector to find out u comma v u into v. Yeah, we want u into v to be 0.
There are infinite such vectors now, all around in circle around this vector with
We will.
varying.
Is there some pattern that those vectors follow? That's what we'll try to find out. Can you delete those parameters a comma b comma c? Okay, it doesn't work. Okay, let's take x comma y comma z. Maybe a bracket inside a bracket, or maybe curly bracket. Curly bracket x comma y comma
Actually,
z
ABC was
in a
fine,
single
right? Instead of X, it was A, Y, it was B.
inside in single bracket. Perhaps that would give us x comma y comma z. This will okay.
I think it's parenthesis, right? Oh.
X comma y comma z.
Try to see perpendicular vector if it's able to directly draw, but that might not be because there are multiple vectors here.
Yeah, take the dot product of these. Will vary the vector v to get 0 comma 0. U comma v. Right. So let's vary v. Can you label those? Can you label those? Yeah, name and value. Name and value. I changed the colors as well. Maybe that would. Yeah. Now for the other one, some different color, not the usual black. Okay, perfect. So now we can see that we have two vectors, right? We'll change the value of our one vector, that is v. We'll try to get 0, and we'll see what happens. Can we change it?
No, I think you place u x y z and then put them in u the v vector. Then you can be changing with that slider.
Right,
Hmm.
that is already taken. I can't take XYZ. Oh God, all the letters are taken. Come on. Okay, B, C, D.
Yeah, right. So v equals to bcd. K equals to bcd. You take the dot product of these. Yeah. Now we can vary it. Can you take the dot product now? Yeah. So yeah, perfect. Now can we vary our vector v here? Can we see if we can drag it to some other value, the vector v?
Yeah. I don't think I can drag it on the screen. I can only change this.
Okay. We will try to change this to get 0, 0.
Or maybe
So
just we
it's
should write 0 is equal to u dot v.
so we are going to near to 0.9. Okay, increase. So move it towards 5.
Yeah,
Towards 5.
done.
Okay, perfect. We have our dot product as 0, right? So is this point unique? Is this vector 2.5 minus 2.6, 0.9 unique? That's my question. Next question. Anyone, guys?
So
Anyone?
any multiple of that point will again satisfy, I guess.
Okay, what do you mean by multiple?
Any scalar multiple of that vector, that minus 2.5, 2.6, that stuff. Minus, sorry.
Hmm.
It's not just about the scalar
I
product.
think
It's about like just if it just has to perpendicular. So any circular, any plane that is generated by rotating it also, the vector containing that plane are also perpendicular.
Yeah, I also
Yeah,
think
yeah,
it's
yeah.
not unique.
Yeah,
Yeah,
it's just the
because
plane.
we are in 3 dimension, so they're
That plane, it has to
perpendicular
lie in
to
a
one
plane.
vector, there'll be 2 vectors.
And all their scalar multiples also means both the things.
Yeah,
So
right. So can we get another point that gives us 0, that gives us 0? So we got one point we got earlier. Now we have another point that is 5 minus 5, 5.2 and 1.8. Can we get another point that gives us 0? So we are only playing with the sliders here. We're trying to find out which point gives us 0.
Can you declare a variable a and then slide it to 0 maybe?
No. Okay.
Is it possible? But how
No,
will I make it
that's not
equal to u?
possible. That's not possible. So try sliding the sliders. Try moving them and getting them to 0. Yeah, perfect. Another point. 1 minus 1.1 and 0.4. So can you all see that the point that gives you the dot product as 0 is not unique, as a lot of you have mentioned, right?
I think this is the same. I think this is the scaled version of it, is it? Not?
I think you go to the
Right.
top view, you can just go across all the points. Then
Maybe
everything.
like if we could check
See,
out which
since
octant this vector is in, the other one would not be in the same octant, right?
see
Then we'll know
this,
it's not.
yeah.
Sorry.
So this vector is actually in a three-dimensional space, right? So there will be what 8 such uh, quadrants where you will have a series of or a set of vectors that are perpendicular to this current vector 1 comma 2 comma 3.
Four quadrants only, no? We are looking at perpendicular.
No, when we look
8,
at 3, it's actually 8 octants.
yes.
See, there is one thing that we must observe is that if we draw a plane spanning these two vectors, that is to say, if we find a linear combination of these two vectors, and then afterwards we find the angle,
Yeah, people don't know what
the-
linear combinations mean and what
no. So what I'm
spanning
suggesting
means.
is that no, I'm again suggesting is that
Hmm.
if we do m1 m2 on that plane, n equals to -1,
Yeah, yeah.
is
So
there a, is there
people
a
don't
is
know.
there a
People don't know
pattern?
that part. People don't know what spanning a plane means, what linear combination means. This is
Can we also say that a plane which is perpendicular to blue line, every vector which belong to that plane will be dot product will be 0.
And that plane passes for only the 4 quadrants, no, not 8. If you see that opposite quadrant to this thing, this perpendicular plane does not pass through that. It will just go through this 2 quadrants upper and 2 quadrants lower, so 4 quadrants.
can you make a plane that is perpendicular to this vector u? Shivane.
Okay. I think what Sanjeev meant was that see when we have a actually to identify a plane we need two vectors. One is a vector on the plane and one is a vector perpendicular to the plane. Right. So
Shivane,
when
can
we
you
have the blue vectors perpendicular, all vectors on that plane which we identified will also be
will be
perpendicular to the
perpendicular
blue one.
to the
Blue
vector,
one.
right?
Yeah, what
Exactly.
he said is
That's
correct.
Yes.
that's what
I
I'm
guess I
saying.
guess I guess that is the motivation. That's why we are learning this perpendicular vectors.
Shivane, can you draw a perpendicular plane to this vector 1 comma 2 comma 3?
I got the second vector as well.
We'll vary it. We'll vary it. We want a perpendicular plane to this vector 1 comma 2 comma 3.
What a plane.
Perpendicular plane. A point and a vector.
What point and what vector?
1 comma 2 comma
1
3.
point can be the origin.
1 comma 2 comma 3, and yeah, you can or we can take the origin and the vector u. So they all lie in these on this plane, right?
Hmm.
Can we get another value that goes to 0? Another value that goes to 0 apart from this?
Only by changing the values, right?
Yeah, by changing the values.
Just see from the sideways now. It will be easy to adjust the values.
Yeah, but okay, I don't want to do that. I only want to look at the. Yeah, I'm just trying to get a slope of 0. Okay, dot product of 0.
Okay, okay.
Yeah, I think Kashish has actually mentioned in the chat
X plus
that
2y plus 3 is
x whatever vector is perpendicular to 1, 2, 3 will be on the plane x plus 2y plus 3z equal to 0. That's correct.
okay. There was a point. There was a point. Yeah, perfect. So another point that is perpendicular to this vector 1, comma 2, comma 3 that also lies on this plane. Can we look at the side view of this plane, Shiva?
Yeah, now it's clear, I guess. You can
Perfect.
see that both of them lie in the same place.
All three of them lie on the same plane.
Yeah,
There
all
are three
okay.
vectors here,
Okay,
and
okay.
all three of them lie on the same plane, right? Okay, okay. So is x comma y comma z unique?
No.
No, right? Okay,
No.
okay, okay. So we've noticed that there will be a plane that is perpendicular to this vector, and every vector that lies on that particular plane will also be perpendicular to this vector 1, comma 2, comma 3. Right? Okay. Does anyone have any doubts regarding this or anything that we have discussed till this point? Anyone?
Maria was mentioning that we need two vectors, one perpendicular to the one to another to define plane.
Yeah.
Was it?
When we have to define there's some equation, but if we have to define a plane, we can have any vector on the plane and a vector perpendicular to it, and we can define the plane.
So in this
How?
case, we gave it a point 0, comma 0, comma 0 that we needed a plane that's perpendicular to the vector 1, comma 2, comma 3, but passes through 0, comma 0. Since all our vectors are defined as points with their tail being at 0, comma 0. So we needed a plane that passes through 0, comma 0. So we gave it a point 0, comma 0.
I understand, but the question is, I'm asking a basic question, more basic
Mhm.
question. Why do we need a vector perpendicular to the vector
Hmm.
to define a plane? Why?
So what Maria was saying that you can see that there is a plane, there is a whole plane that
You
is
don't
perpendicular to.
always necessarily need the perpendicular. If you have two vectors on the
Yeah, exactly.
to
Can we say
confirm
that if we
this.
have two non collinear vectors, then like
Yeah,
if
one
the
is
two
not a
vectors are
multiple of
not
another
dependent,
sort of
any two
vectors, I think you
independent
can get the
vectors.
plane.
What we are doing here is we got a plane that is perpendicular to this vector 1, comma 2, comma 3, and every vector on that plane is actually perpendicular to 1, comma 2, comma 3. So if I give you one vector that is perpendicular to 1, comma 2, comma 3, can you not give me a plane, the complete plane that is also perpendicular to that? You can,
Now we
right?
know this.
You just
Now,
have to.
now we know this
I mean,
after
I think
observing this.
Nishant's question was that do you always need a perpendicular to identify the plane? Wasn't that the
Yes,
question?
which is the
Yep.
definition of plane for be defining, I think. But I do not know why we need the perpendicular.
A motivation behind knowing the perpendicular for defining a plane.
So if you have two vectors on the plane, can't you define it? Because in this case,
I
we're
guess
taking
the
it.
only condition required would be that if they are not dependent, then and if any two vectors are independent, they can form a plane, right? Because they pass through 0,
Yeah.
0. Yeah.
That is very much understood, but what is the significance of perpendicular vector in a 3D space? Of course, two
I
vectors
think
define a plane.
there's some okay. Say you have a plane which passes through the origin, and you know a perpendicular vector to that. So say W is the perpendicular vector, like that's a perpendicular vector, and X, like what do you say? X is the we are expressing everything in vectors. So if it's an R3, capital X will have 3 components. If it's an R2, capital X will have 2 components, and so on. So yeah. So what I'm trying to say is, so if we have a vector perpendicular and we know that the plane is through the origin, okay,
Let's not
The
go
yeah.
ahead.
plane on which that vector lies
Yeah,
will
yeah.
be the
Let's go
perpendicular
slowly.
plane.
Let's go slowly. What we had to understand from this is that, okay, compare this to what we saw. Okay, let's talk about the other questions later, but let's maybe focus on the question at hand. What we saw for a two-dimensional, when we were given a vector in 2 dimension, what was perpendicular to it?
The line with the opposite slope was
Exactly.
perpendicular.
There was a line that was perpendicular to it, right?
Yeah.
But now when we go to 3 dimension,
We
what
have a
is
plane.
it staying as a line?
Now
There
we
is a
have a
plane
plane.
that is perpendicular to it.
Exactly. I think
Yeah,
that's the
that's the
main
main
thing we
point.
have
I
to.
think rest of it's good.
Yeah, let's not deviate too much. So anyone has a point? I mean, does everyone understand that when I go to 3rd dimension, the points that that are perpendicular to, so if I'm given a vector and I want to find what vectors are perpendicular to it, the vectors don't lie on a line, they lie on a plane,
Right.
right? There's an entire plane of vectors that are perpendicular to it.
Correct.
Is that okay? Is that understood by everyone?
Okay, I just had a small doubt. Say you're taking the
So
vector
if we
0,
need
1,
to find a
0.
plane where we need a perpendicular.
Sorry,
The
can you
definition
Didn't
of
get you.
any plane, if you want to define, we need a vector perpendicular to that plane, which defines the whole plane.
Yeah,
Okay.
okay. You're right, maybe. Yeah,
Do
if
we,
yeah.
I
like,
still didn't get
Sanjeev,
him.
can you confirm that? Because, what I'm trying to say is that maybe this will go out
No,
of, like, yeah.
I
Can
think
you
what he's
repeat
trying
that
to
again?
say.
I just
Yeah. So I'll maybe take it up from here, right? He said, so now I know that this vector u, which is 1, 2, 3, is perpendicular to this plane, right? So I can define the plane itself with that vector, which is x
Yeah,
plus
right.
2y plus 3z is nothing but,
Perfect.
right? What is that? It
That's
is
the equation of a plane, yeah.
the equation of the plane can be defined by that vector, right? Because
Right.
1x plus 2y plus 3z is that plane,
Right.
right?
Yes.
So how we
Right.
saw the pattern for the line, right, where y is equal to minus x, the pattern over here is that the plane that is perpendicular to the vector can be defined by that vector in a sense, right?
Right.
I think that
Now
is
I get it. Now I get the motivation behind definition. Yes, Srivina
that's
made
great.
it very much clear. I don't know everybody got that or not. I don't know,
Thanks,
but he made
Sanjeev,
the
for
point.
pointing that out. Yeah, thank you, Sanjeev.
So the thing is that if we take dot product of two vectors, it represents angle between them. Fine, but if we equate the angle between two vectors to be 0,
Yeah,
then definitely we are finding a plane perpendicular to that vector.
exactly.
So that is the thing. That is the motivation behind
Depends on the
definition
space.
of a.
Depends on the space.
Yeah.
If that is a
So,
plane or a line.
of
I
course, of course.
mean, so if
So
we have a vector and say n dimensions, something like that, then whatever, I mean, all the perpendiculars to that vector will lie in some hyperplane of
N
n
minus
minus 1.
Right. Right. We can
correct.
generalize it that. Okay. Now that we have understood this and we have related this to the previous problem, we can move on to the next problem. That is the question number 5. That says that use GeoGebra and plot all the points in the set S equals to alpha of 1, 2, 1,
1 second. I'll just go to the question. Sorry.
where alpha belongs to the reals. Can everyone look at this question?
We have to find a scalar, all possible scalar multiples of a vector 1 to 1.
Mhm.
That's just a line now in 3D.
We'll
Yeah.
Let
see.
us see.
We'll see. What is GeoGebra for? Right?
Okay, can I go to the?
Yeah.
Sure.
Maybe we can delete these or make a copy. Yeah, perfect.
So from now on, I guess we do not need to just mug up this fact that we need a perpendicular to define a plane.
Right.
We know why we need a perpendicular to define a plane.
I liked Jayaneshwar's explanation that it's not plane goes to infinity. It's like just think about it as like having a yo-yo and you need something to hold it in place. Like, not a yo-yo exactly, but
There is this toy, that goes to
yeah,
and
you
fro with
need
the
you need a
on a
pivot to
string,
control something. Yeah.
a reference point.
So the vector is 1 to 1, is it?
Right, 1 to 1. And we need alpha that belongs to R.
Actually, 1 to 1 is a point, right? No, it's a vector.
It's a vector.
Yeah, okay,
Alpha
okay.
1 to 1. But alpha belongs to the real.
Okay, yeah.
So this is it, I guess.
Yeah. We're
Srivani,
done
I
with
think
this.
someone's asking for the previous GeoGebra link in the chat. Like, if you have
Sure.
that, see.
1
I
second.
think that's deleted.
No, I saved it. No worries.
So, yeah, that's.
This one, right?
Can you open it and see once?
Yeah, this is what.
Yeah, right. This is the one. There must be a share link, right? Yeah, just copy that link. There was a link, right?
Yeah, there was. I mean, it said link, but then when I click the link, it's.
Just
Can
copy
you?
the link in the address
There was
bar.
an option copy activity link, maybe that's.
Yeah.
No, just copy the address bar. I guess it will lead to the same page.
Share with link. Okay. How do I get the link? My bad. Should I just try to? Yeah.
Yep. There you go.
Sorry. Very visible, right? Okay, I'm using A as alpha, and now I'm varying alpha. Maybe. Yeah, I'm varying alpha. I can be a bit smart. Sorry. Okay. So use GeoGebra and plot all the points in the set below. Alpha 1, 2, 1. Right? So if I plot it, how would I plot it? May I unmute? Can you guys hear me?
No, yeah.
You're audible.
Okay. I think everyone's just taking a break. Do you guys want to take a break for a minute or two before we go ahead?
No, we must go ahead.
Hmm.
There are not many questions, I guess, for the
Yeah.
day. Only yes, 3 of them left.
Yeah.
Can
So how would I
finish them.
plot all the points on this? Can anyone tell me how would I plot it? How would I plot it?
Just draw a line now that passes through origin and one of these points.
Okay. So I draw a line that passes through 0, 0, 0 and U. My bad, 1 second. Is the screen visible?
Yes, it's visible.
No, the graph is not visible.
The screen is visible.
The plot is.
My laptop is hanging. 1 second. Yeah. Sorry. Just give me a second.
No.
How did we get to 2D?
Just click on GeoGebra. That will lead to your home.
Yeah, but
Home
this
of
one
this one.
wasn't saved at all. No?
Oh,
Just
sorry.
hoping it's saved. If it's not saved, maybe you have to start from beginning.
Yeah. That has
You mean
gone,
to
I
say
guess.
that is gone only? It is not because of delay or hanging.
Yeah, because of the reloading of the site.
My bad.
Yep, cache is gone.
Let's see.
I guess we can discuss all of the remaining questions in this GeoGebra page only, because all of them are related from now on.
Related, yeah.
3D calculator doesn't seem to open.
Let me check. I'll check if their server is down or what.
For the first time, so many people are using GeoGebra. I think they're happy. They're like,
No, it is working actually. The server is
It's,
not down at all.
it's working. It's working. It happens,
Yeah.
that day my computer was hanging because of some sort of
maybe I'll stop
because of
sharing my
internet.
screen.
Maybe restart your system itself.
Oh no, yeah. Restart the page and close it and open it on something. If that works.
Or on a new browser, maybe.
Yeah, that too.
I don't know if it is related to a RAM or network or what. I don't know.
It's open. 2, 1. What
No, it's
did we
working
do?
fine now.
Yeah. Okay. And we had A times U. What did I need? Yeah, let me just vary.
273. Next vector is 273.
Oh, do you not want me to plot the line? Should I plot the line?
Yep. Maybe plot it.
Okay. And Yeah. This is the same thing we had last time. Okay.
Mhm.
Maybe I'll hide this. Okay. So it's spanning. So with that one vector, I'm able to scale it, and as I scale it, I get vectors that fall on that line, right? I think that's what we're trying to observe here. We are observing that if I take a vector 1 to 1 and I scale it, which is nothing but say alpha times that vector or a times that vector, the resulting vector just lies on that line, that the line that is passed through 0 comma 0 comma 0 and the vector 1 to 1. And it's maybe you can think of it as a scaled version of the vector, right? Yeah, that's all that
Yeah.
this question is.
Maybe we can just declare this term as span of a vector here itself. It is convenient.
Maybe. Do we want to use that? Did sir?
Because upcoming questions are, kind of would point in that direction. Span of vectors.
Yeah, like the simplest definition that Ashik said that one day is wherever you can reach with the combination of
Yeah,
the
but if I
vectors.
take a
Yeah.
single vector and try to explain
Yeah, say
span,
the span,
it's
it's
not.
not.
No. Not the concept of span. Just in this case, what happens to be span? Because it is very simple now. Afterwards, as we progress, because there is related questions afterwards, people would be able to relate to the concept of span. Otherwise, when we start the topic of span, we'll have to start doing this yet over again.
Yeah.
Yeah, we'll digress. But yeah, still I guess the single vector defining span for single vector would be also
It's
not
okay.
so
Maybe
this,
we
but
can
yeah,
just define it for this one vector and maybe we can see how it generalizes for others.
yeah,
So,
sure.
so with this vector, I am able to reach all the points on this line, right? I can scale the vector with any value between minus infinity and infinity. And I can essentially reach all the points on this line, right? So the term that we may, become maybe the term that is used in linear algebra to express this, which is where all can I reach?
Let's use the term manufacture rather
Yeah,
than
manufacture.
span.
Sir also uses the term manufacture. So with this one vector, I'm able to manufacture
All
any
of the
vector.
vectors on the line.
Yeah, any vector that falls on that line. Exactly. Yeah. And that whatever I can manufacture, I call that, I say that that lies in the span of this vector, right? So that is a term that maybe it makes it easy to use, or like it's a jargon basically, but maybe once you know it from first principles what it means, maybe it will help you understand other concepts as we go along. Yeah,
And
is that
for
okay?
in Hindi there is a word called ilaka. Maybe the ilaka of a vector is the span of a vector.
Yeah, the region.
See, ilaka means where somebody finds comfortable to roam around.
Okay. So can we go to the next question? So we were able to find the set of points, right? What are the set of points? The set of points that lie on this line. Any point that lies on this line.
Should we find the equation of the line? No, right?
We have to find, okay, do you want to find the equation of the line? Or can someone tell me the equation of the line maybe with the vector? How would you express this? How do you express this?
One point is the origin, so that makes it quite easy.
If you know a vector, definitely one point is origin, then we can write a formula for
We can forget the
equation
points.
of 2 point, line.
Equation of the line in R3, yeah.
You want me
That
to write
is
it down?
y2 minus y1 upon x2 minus x1 into x2
Mm.
minus x1.
But instead of thinking of it in that way, like when we have like just think of it like easiest way to think about it is if we have 1, we obviously know that, and it passes through the origin, we obviously know it's y equal to x. So here we have 3 points. So maybe thinking of that instead of using the equation is easier on the mind.
If it passes through
Yeah,
0, 0, why is y equal to
one
x?
no,
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 I
no.
mean,
Why
yeah,
one point happens to be 0, 0, 0. So this complete formula, of course,
Oh,
boiled becomes very easy after.
yeah, that means we don't have a constant in the. That,
yeah.
yeah. Okay.
I mean, I don't think that's that important when we're discussing, but if anyone wants to try, they can do that. Maybe 2 minutes.
Else, if we know the slope of this line, we can easily write is equal to y is equal to mx.
Here
As
it's in
simple as
3
that.
dimensions, right? So it's not y
That's
equal to
why,
mx.
of course, we cannot do that.
You will require at least 2 theta's to define it accurately.
Yep,
But that's complex.
Yeah.
yep.
So why go
Ax
when
plus by plus c would be more appropriate, I guess.
Ax plus by?
Yeah,
Oh,
do you need d when
but
you know that
because
it
of
passes
that
through the
you already
origin?
required, no?
Yeah, you're right. Yeah, but this is actually just the way ax plus by plus cz equal to 0. And then you just plug in the point values.
Okay, which question are we discussing? Can anyone tell me that?
Yeah, we were saying that
Third
like
from
alpha
last.
times 1 to 1 would span a line. So we were just asking if anyone knows
Mhm.
the equation of the line in 3 R3.
Okay.
Can somebody tell the equation of the line?
Kashish says the equation of line is x equals to y by 2 equals to z.
Like Kashish, can you unmute yourself and say how we got to that answer? Maybe others can also.
It's a method it is x minus x1 by the vector by a is equal to y minus y1 by b is equal to z minus z1 by c.
Yeah, that's the form. Yeah.
But is there a simpler way to find? I mean,
Maybe like what Jainendra mentioned is like an easier way. First, you just write ax plus. Actually, you only have 2 unknowns in that because others will be just multiples of that. So you only have 2. Actually,
no, isn't the equation of the line equal to ax? Okay, let me write it down. Uh, One second. Not connected properly. Okay, so I know that.
yeah,
Okay, we have 2 information. Yeah, everybody.
I know. I was thinking if I made a mistake, like, can you do that without using the formula that x minus x1 by a equal to y minus y1 by b equal to, that is, a, b, c are the intercepts and it passes through x1, x2, x3.
Then it
Other
will
than
come
that,
in form of ij cap.
Yeah, you can think of it in terms of ij cap, but what does I signify? It's just 1 unit in the x direction, right? And j cap is telling you 1 unit in the y direction, and k cap is
actually, yeah, that was the thing. Like what Jainendra mentioned in the chat is the equation of a plane. What we have to find is the equation of a line.
yeah.
Yeah, that's what I mean.
Now, before going in that direction, I think we should also consider what if our this space increases, like we are just calculating an R3, three-dimensional space. But when vector have 4 component, and if vector had 5 component, if vector sometimes they have 1,000 components, then this kind of approach is not feasible for a lot of calculations. So I think we should stick to a method
No,
that
but if we know one point is the origin, then it's not that difficult.
no
You
parametric
just have
function.
to, like, if you know that one variable will be a multiple of another, right?
Just write simply it in parametric form, then no issues are related to that slope and the rest of the things. But we cannot scale this method in higher dimensions, no? That will just
Yeah.
bounce to three-dimensional space only.
No parametric form, no slope.
No, I think okay.
Yeah, we can actually try staying okay. Yeah. No, like, let's not use all the complicated terms. Like, that's something we try to do in this meeting. So, like, the only way, one point is like, say, okay, like Ankit asked this question. Say you have 5 components. Let's call them x1, x2, x3, and we have 1 point. Then how would you do it?
Five components and
And we know it's passing through the origin, of course. So is it that difficult? Do we need the equation or some sort of formula to actually come to the equation?
when we consider a vector picture, and if you want to represent all its combination, that is just a scaled up or scaled down combination, we can just easily write it as alpha and vector. Can you frame your question again if you are asking something different? It can still be a line, no?
Yeah, like maybe use GeoGebra. Okay, that's what Sir says. Okay.
No, we
So,
can't use GeoGebra for this. I'm just saying
Yeah, we can't. Oh, yeah.
we saw it for a 3 dimension. That's the best we can see, right? We saw 1 to 1, and then we tried to scale it up and down, right?
Mm-mm.
And then we realized if I scale it up and down, I can only go across a line. I can span a line, right?
Yes.
So if I
Okay, okay.
take it,
Sir has actually asked
So,
us to
so
only use 2 or 3 dimensions. So I think we can
yeah.
move
So,
forward. Yeah.
friends, the point is to converge to a bigger theory, right? So, if we get in n dimensions right now, it will not only confuse you people, it will not help you understand the big picture. After a few modules, we only discuss n dimensions. We never come back to 2 or 3 dimensions. So right now, please ensure that you work only in 2 and 3 dimensions and use only GeoGebra. Avoid math as much as possible, because it gets fun to reach the big picture through GeoGebra only. Right? Let's take a
Yeah,
less
yeah.
Spang approach, less mathematical approach, and more intuitive approach.
maybe we should plot the next vector,
Yeah, anyway, someone said the answer to the question. It was x by
Okay.
2 equal to, sorry, 2x.
x is equal
X
to
equals to y by 2 equals to
y.
0.
Yeah. Okay, I think that's okay. I mean, we know that it spans a line. Maybe we can go ahead. So what if I do it for the vector 2, 3, 7? That's the next question, right?
273.
Yep.
273.
Yes, 273.
Just,
Sorry.
just same question, just the coordinates have
Values are
changed.
different, yeah.
Just to find a new vector.
I mean, just to make the session more interactive, like
W.
obviously,
Not
can
W,
anyone
not
say
W.
what does this set of vectors manufacture? Anyway, we did a similar question, right?
No.
Someone
You
who
do
wasn't
AUV.
responding before, maybe.
Let's go to AU. Yeah. Maybe do MN for A for scalars. Is that?
This is 273, right?
Yep.
Okay. And now I want
Now the next question. I guess we are done with this question.
Z. I mean,
Now we
Z.
have to find out what we would call actually a linear combination. This is the main question at our disposal, I guess. This one and the next one. We must show how, in GeoGebra, how if we add these two vectors and kind of span it, then
Yeah, just give me a second.
what does it represent?
3 times. How do I see underscript 1? Yeah, okay. I can't see the vector.
It's not kind of
Oh, I think it's
spanning.
okay.
Your C is closed.
Again, this is the same thing as before. We can see that it has a line. Maybe I'll plot the line as well, which is and C. Right?
This is it at similar line.
Awesome. Okay, we understood that. And now, yeah, main question. Use GeoGebra and plot all the points in the set below. Alpha of 121 plus beta of 273.
273. Does that alpha and beta both are reals?
Real numbers.
Okay. So now let me remove what all is not important. We
Just keep two vectors.
will keep U and C1. Right? Okay.
Yeah.
These are the two vectors. Everyone can see the two vectors. Yeah, I think this is clear. And now I want to take A
No.
time.
No, do not keep this. Keep the line of them, both of them, because that is what we would signify alpha and beta times two vectors.
Oh,
We have to find some of them only.
No. Okay.
Isn't it?
No, okay. Let's see what happens. If it's not clear, then maybe I'll change. So alpha into U plus beta into Z1, right?
We collapses a dimension.
Do you want me to keep this and this instead? That's what you're saying? Because the addition of this is what is yellow, right? I mean, if I change B, I can see this changing. Isn't this better? I can see as I change blue where I'm going, as I change red where I'm going, right? This makes sense.
Yep. We will generalize it afterwards. Let us move ahead with this only.
So 1 times this vector plus 1 times this vector is going to 3 comma 9 comma. Okay, let me delete all this. I don't think we need this. We need this. We don't need this now. Because I want to see all three in one place. So as I change,
Why don't you just draw a plane and see if they lie in the same plane?
I mean, we want to see what it's done. So I think,
That would be our conclusion.
yeah.
Hmm.
So where all can I reach with these two vectors is the question, right? If I scale the second vector, I'm able to reach somehow in this direction. I'm able to reach in this direction. Where all am I able to reach? So what does this create?
Maybe
What is the
just
set of
make
points?
you. First of all, let us
Is it
make A
the
and B.
complete
A
R3?
and no. 1 second. Let us first make A and B is equal to 1.
That's what I
This is important, to go stepwise. See, now, as you can see, we have got two vectors, which are the V and V and Z1, I guess, isn't it? And we are doing a vector sum of both of them, if you could say.
B and C.
That happens to be W.
Yeah.
If we just do a vector addition, we will find this. 2 plus 1, 7 plus 2, 4 plus 3 plus 1. Fine.
Yeah.
Now, if we scale these two vectors, we get two different lines. We have seen that. Similarly, what if we scale the sum of these two vectors? We have to see that. What does that signify? We have seen we scaled these two vectors individually, and we saw that we call it a span. Basically, it spanned a line. And now we have to see what the combination of these two vectors is going to span. I mean,
Maybe use
what all area?
manufacture instead of span. Yeah.
Yeah, we
what
don't
all
know what
area?
span is.
Now we kind of discussed, a little bit, but still, if we are not going to use the word span, let us see, where this vector
Better.
combination of these two
We
vectors
can
go.
see that what type of region can we cover in three-dimensional space.
Let us
Right.
see if there is a pattern. Is it traveling anywhere in the 3D space, or is there some pattern? We are just about to see that.
Okay, so I'm going to add 2 times the first vector to 1 times the second vector. So 4, 11, 5. So I'm getting 4, 11, 5. And 2 times and 2 times this vector. What was the previous point? It was, okay, let me maybe do that.
Is C actually required?
No, I'm just showing it so that because blue plus red gives us yellow, right?
Yeah.
Yep. That's fine.
Okay.
Right? The blue vector plus the red vector gives us the yellow vector. Or do
Yep.
you want something else? It's okay, right?
Hmm.
Okay. So I'm able to reach 392. Let me maybe write that as m is equal to 3, 9, and 2. Right? I'm able to, 3, 9, 4 is it? Sorry. 3, 9, and 4. Right? I was able to reach 3, 9, and 4 with 1 times the first vector and 1 times the second vector. Right? I was able to reach 394. And
Maybe plot points, make points, and later on we may join them.
you want okay.
This is the point where we are reaching now with this combination when A and B is equal to 1. Let us now start varying A and B and see where we are going. A1, A2, let us do it A1, A2 because we'll run out of alphabets eventually.
So if I take 2 times the first vector and add it to 1 times the second vector, I am reaching some other point, and that point is 4, 11, 5. Okay.
A1.
B is equal to, okay, you want to go A1. 4, 7, 5. Is it not 4, 4, 11, 5? Sorry. Okay, I was able to reach 4, 11, 5. And what if I do 2 times the first vector and 2 times the second vector?
I mean, you can select any combinations, I mean, you can select any value of A and B.
I know.
It's
I'm
not as
just,
if that. No, I'm not saying to you. I'm saying that, anybody who wishes to just input something, could say, and we will just do that input. Even if we make a random input, we'll find a point.
Yeah, anyone
a
who wants
resultant.
to give us a point? Or maybe,
Anyone?
yeah, what about
Just take 2, 8, 10.
2, 8, 10? 2 and 10, is it?
No. 2 and 10, yes, 2 and 10. AB.
Wait a second. Okay. I am able to reach 4, which is 22, 74, and 32. Right?
We can keep doing this all day long, keep varying A and B, and we'll get different points afterwards for the resultant vector, of course. But is there a pattern, that is what we have to observe. Is this points following a pattern? Of course, that is not obvious to our naked eyes if we just look at the numbers. What if we look at something via, the graph itself, 3D graph? Vinay, can you do something, so that we find a pattern?
I mean, okay, how do you want to go around with this? I'm not sure what you mean.
I mean, to say that we have to find a plane, how do we proceed from here?
Yeah, okay. I mean, we can't show every point on a plane, but how do we go ahead? Yeah, and I'm not sure. Is Sir around? If Sir wants to
Yep.
maybe tell us how to go around with this.
You can just draw a plane using any vector in 0, 0, 0 and see that does rest of the vectors lie on that.
Yeah, maybe I can do that. Yeah. So,
Yep, that
okay,
is what I was asking.
maybe I write.
Vectors spanned by linear combination of two vectors. Span of linear combination of two vectors. That is all what we have to find in a jargonic terms.
You can try Googling and seeing how it is done in GeoGebra. I don't seem to remember it off.
Okay, sir.
Okay, we have got more questions.
Why don't you run both the slider and fix an angle that shows that the resultant is only covering a plane?
We'll need we'll need a equation or a plane, equation for plane or a plane itself.
Yeah, I
So
mean,
that we
it'll be
can
easier to reference that if there's a plane. Yeah, you're right. Span one, span two. So ours was what?
I'll tell you two vectors, na?
What are the first and second vector?
1, 2, 1 and 2, 7, 3.
1, 2, 1. Three.
Yep.
So these are all points on a line. So, okay. Yeah, maybe we can go. Okay, maybe I'll zoom in. Okay, Zoo doesn't
Maybe
really
from
zoom
a
in.
from a maybe show from a different direction. If what are those traces making?
Yeah, yeah.
This is basically locus that we are looking at. Locus of the resultant vector.
So
Do we
I
get a
fixed,
pattern out of it?
yeah, I fixed B is equal to 1 and I am changing A, right? You can see that I'm able to span that entire line, an entire line of points, right? And what if I do that for every value of B? So now I'm spanning another line, right?
Good, really great, great.
And what if I change the value again and I span that? Now you can see that we are slowly spanning, lines which are moving along. I mean, they're kind of parallel.
Passing through the origin.
Yep, they are. They're not passing through the origin.
No, they are not passing through the origin.
Why would they pass through the origin? I mean,
Oh no, sorry. Yeah.
yeah, I'm able to reach every point on this line, and if I vary B, now I'm able to reach another line which is kind of parallel to it, right? In some sense, that line is parallel to it.
I think you're still
We'll have
A
to.
only are.
No, he's doing it rightly. Srivana is doing it rightly. Eventually, we will cross the origin.
Yeah.
We are actually see this kind of 3D printer.
Dot matrix printer, you know.
Dot matrix 3D printing in 3D. Actually, this is what we meant by locus when we used to study locus in our high school days. This is what we mean by locus. What
Yeah,
are the trace points, of a particular pattern followed by a point? This is what we are doing here. Maybe value. Just let us do this.
So
It's
now,
fantastic.
like I can change B to any value, right? And you know that B has an entire line. So across the line, I'm cutting lines, right? So we can see that I can fix a point on the line, and I'm able to like change the value of one of the scalars, right? The first vector, the scalar that is scaling the first vector. If I fix the second vector's scale, and I change the scale for the first vector, maybe I can even share this link to everyone.
No,
Or Google
I'll
it as
just
well.
say one thing. We were just, making note of points of the sum of two vectors. Resultant of the sum of two vectors. We were making note of those points. Na? These are those points.
Maybe some letter is coming up, I guess. You look at it from another angle.
Yeah. So what I'm trying to say is, see, okay, now instead of me trying to move this around, right? I know that when I fix the B value, wherever I am, I can go along a line, right? That's what the changing of A means. So if I keep changing B, every point that I'm reaching on that B, I can actually reach a line across that B, right? Whatever point I'm reaching there, I can actually reach an entire line. So
Yeah.
that means I'm kind of creating a line crossed by multiple, like infinite lines which are like cutting across each other.
Yep. Like a graph paper, isn't it?
Yeah, exactly.
For every horizontal line, there is a vertical line.
You think of it more pattern. Yeah, exactly. So you're able to span an entire
Plane
plane.
out of it, huh?
Yeah.
Eventually, we get a plane.
Right.
Yep. That was it.
This one, right?
There you go. Yeah.
The entire
You see,
plane, which
this is
has
a plane.
all these points. Yeah.
Yep.
Okay.
Yep.
I think
So
this
we have a
point.
pattern.
Yeah.
That was our, concern. That is what mathematics is all about, to find patterns. And we have got a pattern, a geometric pattern out of combination of two vectors. isn't it? Maybe we can move to next question,
Yeah.
We can
So this
then
is
we
very
can say
important, right? So
something
you were able
more
to
about.
take two vectors.
Has everybody understood this?
Yeah.
Everybody in the meeting.
We do not have very much of them in the meet. At least we can agree if we have understood. We all have understood this thing that we
If
just.
you
It would be
guys have
nice if all
not
of you
understood, you can just raise your hands that we'll go through this question again. No worries. You can just raise your hand if you have not understood any part of it.
But it's actually quite cool, right? Like the way it actually reaches an entire plane of points. I mean, when you normally learn this theoretically, they never show it to you geometrically how you reach the entire plane. So, like when you use GeoGebra, that's an advantage.
No questions, right? Nobody is.
No,
Okay,
here
right. See, okay,
one
we can. I have a doubt. I have a doubt. Okay, I don't understand this question. Maybe others are smart. I'm not. So, can you explain me this? Yeah.
Which exactly? So
I have
you
one
want.
question. Like, if we are given one vector, if we join one of the previous this concept, one of the previous questions,
Mhm.
if we have a vector and we wanted to find a vector that is perpendicular to that in a certain plane,
Perpendicular in
Which
a
certain
certain
plane?
plane.
yeah,
Which plane? You have to tell me if it is like an R2 plane or an R3 plane.
means R3. We are talking about R3 now. All the vectors are in R3.
Can you just requote your complete question?
Yeah, like just same. Uh, you have W1 here, we
Right.
have W2 here.
Hmm.
Now, what we want is we want a vector that is perpendicular to W1 but is in the plane of W1 and W2.
Perpendicular to W1 and is in the plane of W1 and W2.
Yeah.
Why?
He
Uh,
just wants it.
no. Few days back, if you remember that we tried QR decomposition, and
Yeah,
that
let's.
first column calculation was easy, but when we want to calculate the second column, we didn't get an idea. But here we can see that they are like what the properties of what that was. The vector should be unit and perpendicular to each another.
Yeah, let's get
No,
to that
better.
maybe
I
after.
guess I no no. We
Right.
can discuss better fashion if we know greater patterns behind this, formation of this plane. That is what next question is all about.
Okay,
If we have, if we get to know how matrices are kind of implied and used, to define a plane, and this especially this sort of plane where there is when a plane is getting formed out of combination of two vectors.
Before we move to the next question, can we go through this question once again?
1 second. Okay.
Sure. Why not? Chetan has a question actually.
Yeah, I don't understand anything. Yeah,
Yeah.
we can go
So
through this again. Yeah.
yeah. So
Mhm.
first, let me load the trace.
So just show the question once again, and we'll go step by step again. Yeah, thank you, thank you for that.
Oh yeah, that figure is pretty cool.
So this is the question that use GeoGebra and plot all the points in the set below. So we have alpha times alpha of 1 to 1 and beta plus beta of 273. Yeah, go ahead now.
So what do we understand here? We have two vectors, right? 1 to
Right.
1 is one vector, and similar to what we saw in question number 5, when we scale that vector
Scaled by
alone,
some. Yeah.
right, we were able to reach every point on that line
Correct.
on a particular line, and that line passes through 0 0 0 and 1
And
to
1 to
1.
1. Correct.
Yeah,
Perfect.
that was a property of that line. Yeah.
Right.
And we saw the same thing. I mean, the same thing can be applied to the second one.
Alpha and beta are just scalar quantities that we are scaling the vectors by. That's
Yeah, exactly.
perfect.
So now I want to see what all points I can reach by adding the first vector and the second vector.
Right.
But I won't just be adding them. I will be scaling them appropriately and then adding them. So
Right.
I can scale them from minus infinity to infinity, just like how we did for the question number 5 and 6. And as I'm scaling them infinitely, right, I will take the sum of them and I'll try to find out where that
Read
point.
another vector.
Wherever we can reach, right?
Exactly. Where
Okay.
what points
But
can I
all points we can
manufacture?
reach, right?
Manufacture with these two
Correct.
combinations. Yeah, awesome. So to do that, we need the two vectors. Let me
1 to
subtract.
1,
Yeah,
and the another one was
273.
273. Perfect.
Now we
So
can see A is equal to 1, B is equal to 1, and the linear, like the
right,
sum of those two, A W1 plus B W2 is equal to 394.
right.
Awesome. So this is the first thing. So first of all, let me ask this question, right? If I'm able to reach 394, does that tell me something about a property that, okay, my vector 1 to 1, right, I was able to reach 1 to 1, right? But with 1 to 1, where all was I able to reach? I was
All
able to
the
reach
multiples of 1 to 1.
exactly, right? Can I try kind of project that idea to 394 such that, okay, I'm able to reach 394. Does that mean I can reach any point on the line lying on 394? Have you thought about that?
Yeah.
Yeah, you can. When you take alpha and beta to be the same.
Exactly. So if, okay, so I was able to reach 394 using 1 times 121 and 1 times 273, right? What if I make A is equal to 1.1 and B is equal to 1.1? Or maybe to make it clear, I will just take 2 and 2, right? I'm able to reach 6, 18, and 8. Previously, I was able to reach 3, 9, and 4.
Cool.
And now I'm able to reach 6, 18, and 8, right? 6, 18, and 8 lies on the line that 394 can reach. And I can do this for all combinations where A is equal to B, right? Right? Can you see that if I'm able to reach a particular point, right? I can actually, because I am changing the scalar factor for two vectors, right? I can always keep them, scale them by the same amount in a different, I mean, scale them by the same amount and reach another point on that line. Right.
Yeah,
So
by keeping the ratio same, I guess.
exactly. So can I say that if I'm able to reach 394, I'm actually able to reach any point on the line that passes through 0, 0, 0 and 394. Right? This is a very neat idea, right? This is the laws of linear algebra. I mean, these are the rules of linear algebra. If I'm able to reach a point, if I scale it to 0, I should reach 0, 0, 0, right? And if I scale it by any amount of minus infinity to infinity, any point on that line passing through 0, 0, 0 and 394, right? So when I'm fixing b is equal to 1, let's trace the points now. I'm fixing b equal to 1, right? Laptop is frozen. My bad. My laptop froze for a second. Sorry. Let me do that quickly again. One, two, three, right?
Fine.
Okay, we're able to reach 394, right? Now I want to keep 1 point as constant, and I'm going to vary, I mean, one scalar. So I'm scaling one vector by only 1, the second vector by only 1, but I'm scaling the other vector from minus infinity to infinity, right? What are these points? Where are these points lying?
In a plane,
Yeah.
right?
No. Are they lying on a plane? Where am I able? What are these lines? Right? Maybe I'll look at it like this. Right? What
Right.
is this?
A line. Right. A line.
Exactly. Right? I'm able to go through an entire line. Right?
Correct.
For b is equal to 1, I am able to go on one particular line. What
Okay.
if I make b is equal to 2,
Another line.
right?
Right.
I'm able to go another line which is parallel to the first line, right? Can you see that
Yep. Yep.
the first and second line are parallel?
Yeah. Yeah.
But this is true for even all the points between,
Points.
right? You see this point over here, this point over
Right.
here, this point over here. These are all intermediate values for
So if we
the other
vary
people.
B and then yeah,
Yeah,
we can get another line. So if we vary A now, right?
yeah, exactly.
So similarly, we can get for all points of where A and B can vary, we can get a complete plane.
Exactly. For all the lines that I'm going through now, each of them will have a line for itself,
Correct.
right?
Look, for plane, we need 3 points. We already have two factors. So we already have 2 points and one is origin. So using these 3 points, we can draw a plane also.
Hmm.
Yeah, yeah, true. If we have 3 points, we can draw a plane as well, right? Origin is 1 point. The other 2 points can be represented as the points, the points as represented by the vector, right? Awesome. So, but visually, what does it mean, right? So the line that I've done that is going across like this, maybe, yeah, this line, right? This particular line, each of them have a line which is parallel to this, right?
Right.
Which it can span, right? And when you look at the grid, it looks it if you try to put all those points, uh, all the points that it can reach, right? I'm only varying b from -4 to 4, right? What if I do it for minus infinity to infinity?
Right. Right.
Right? I can actually go through all points that are
And
like
get parallel lines for those
exactly
points.
parallel lines. Yeah, exactly. And together they form a plane.
Yeah.
That's
Right.
that's what it is. Yeah. So is that clear for everyone?
Guys, if anyone has not understood this, you can raise your hands.
Yeah. And if you have understood it, maybe give us a thumbs up.
Give us a thumbs up.
I'm not sure how many of you have understood or not understood. I'm really not sure.
Okay, one thumbs up, two, three.
Thank you, Praneeth. Thank you for that.
Anyone
Good.
who's new to the session and has not understood this?
Okay, let's just move forward then.
Okay, okay, perfect. Okay, let's move to the next one.
Yeah. Sorry for taking too much of your time. So this will be the last question, maybe.
Yeah, yeah. So in the above set W, find out all the points x comma y comma z satisfying the following. So we have W1, W2, and W3 as row vector, and x, y, z as column vector. Together they give us output 0 comma 0.
They should give us output 0, I'm thinking.
Mhm.
Right, sir?
It
Here
should.
we're looking at W transpose X, right? It gives us a 1 cross 1 value. So the right hand side should just be a 0, right? If sir is available, maybe. Yeah, let's clarify that later, maybe.
Mhm.
That's right.
Yeah.
Right hand side is origin. Origin is in, it should give you a 0.
Yeah.
And your W1, W2, W3 are actually the vectors coming from the previous question. You should figure out all those X, Y, Z, which is going to give you 0. I'm sorry, there's a typo there. It's not vector 0, it is scalar 0.
Yeah. That's the same thing for all the
Yeah,
questions,
for
right?
all the
Okay.
previous ones as well.
For all the questions, it's the same. I made a mistake, typo. We should correct it. I'll correct it in the MD file on the website.
Sure. Thank you. Okay, so now we're trying to, so W1, W2, W3 are vectors from this set of vectors, right? W1, W2, W3 are coming from W,
Right.
right? Capital W. And isn't that a matrix? Oh, actually that becomes a matrix, right, sir? If you take three vectors from,
Yeah, it is. I think it is.
yeah, it becomes a matrix, right? W1, W2, W3 as vectors would be a 3 cross 3 matrix.
No. W1, W2, W3 are elements of.
Points. Okay.
No. Come down in eighth question.
W is the set, right?
Where W1, W2, W3 are elements, is an element in W.
Okay. It's a point from
So
W,
it's
right?
a point in R3.
Okay.
It's a row vector.
Okay. Understood.
So which means the product will be 0 only, scalar 0. Basically, it's a dot product.
The plane function and provide the 2 points and the origin. Okay. So since we have 3 points, let me maybe make a plane that contains those 3 points, right? That might be a better way. Instead of including 0, 0, 0, I can make a plane of 3 points W1, W2, W3 and see what that gives us. Can I do it in this?
In W1, W2, W3 are scalars. All of them put together is an element of R3. W1, W2, W3 is an element of R3.
Then how do they come from the set?
They are
I
points
think
of W, capital W.
Points.
They are the points that lie in the plane now that we
Yeah,
just.
but a point in itself
Correct.
is
Perfect.
x comma y comma z, right?
That's just a notation now. Yeah? I have drawn this thing. I have included in the chat. This question.
The coordinates of that point are represented by W and W.
Okay. You're just representing the coordinates as W1, W2. So 1 to 1 would be one of those coordinates, right?
Mhm.
Okay, that's better. Okay, I understood. 1 second. Let me save this once and check if this is visible for you all. I'll open the one multi-session.
Yeah, it's visible.
Maybe what is this gray vector? Not able to select the vector. Now I want a plane. So let me do it. So I want a plane that has 0, comma 0, comma 0.
Rest of the two vectors, no? Just
Yeah.
set the vectors A, comma B. This is your W plane, no?
So Now,
Now
let's
we
go back to
want
the question.
something
Yeah.
that is perpendicular to it.
Yeah. So we saw that this plane is what now this plane is what I mean this plane kind of I lost it again. Why is it? Oh, this one. Yeah. So this plane is all the points that the that the two vectors can kind of reach, right? By taking the scaled version of each of them and adding them up. So you're able to reach every point on this plane, right? And now the question is, what values go to 0, right? Okay, you want to no. So what values of x, y, z is kind of perpendicular to this plane, right? Okay, how do I read this question, sir? How, I mean, do you want me to read it as a perpendicular, or do you want me to read it as
We
the dot
want
product?
we
Yeah,
want
see this simply as
Dot product of two
um,
vectors.
yeah, I can call it dot product, I guess. That's okay. Most of us are familiar with it. We call it dot product. Refresh it once. Refresh this once.
So the typo is still there.
Yeah, it's still there.
Yeah.
Okay, let me quickly finish this then. So the dot product of any vector in this plane, right? So any vector in this plane can be represented as, so any vector on, sorry, any vector on this plane can be represented as W1, W2, W3,
Hmm.
right? So coordinates of that point on that plane. And I want to know that the,
Dot product.
yeah, I want to know what vector when I take the dot product with gives me 0, 0, 0, right? So can anyone tell us what would that vector be? Or maybe what is the property of that vector?
Should be perpendicular to this plane.
Exactly.
Bravo.
So
Perfect.
it should be perpendicular to that point on the plane, right? And if it is perpendicular to that point on that plane, we can call it perpendicular to all the points on that plane. Is that true?
Yep.
Right? So maybe how do I do this? I have a,
Yeah, so that means a perpendicular to a plane is unique, or it can be the negative, I guess.
yeah, the perpendicular vector to this plane.
Yeah, I think
Yeah, if I think of the vector, it can be only one vector, right? Because that has to, okay. So if I think of a vector that is perpendicular to this, right? I would think of it somehow to be like, okay, how would I, what is the best way to think about it? From this angle, is it? Something that's cutting across this plane, right? Something that is cutting across this in a 90-degree fashion, right? How that's how I would think about it, right?
mm,
So there is only, so how many such vectors could be there?
only one vector, no?
Yeah, yeah. So let us try to find such a vector. Let me initialize a vector v, uh, 1 comma 1 comma 1, right? And
actually, I had a small doubt. When we were discussing earlier, we said that I don't remember exactly, but didn't we say that when we have, okay, that was a vector. Like we had when, okay, a perpendicular to a vector in say R3 would be, you would have two vectors which are perpendicular to a vector in R3, right? But there's only one vector that's perpendicular to the plane.
yeah, because the plane is okay. So
Perpendicular to a vector can be many in R3. You have a whole plane that is perpendicular to a vector, right?
Yeah,
Any
sorry,
vector
that is
lying
true.
on that plane is perpendicular to that vector. and vice versa is true as well. So there will be only okay, for a plane there will be two vectors, or if you want to say
Further,
like
it is scalable.
single vector in a single line, uh, or
Yeah. Okay.
multiple
That's
vectors
the
in a
word
single
where
line.
I made a mistake. Like, okay, it's perpendicular to vector in R3 there would be a plane, and
Yeah.
And
we can
to a
say that the
plane it will
span
be a
of a
line.
plane and a perpendicular is kind of unique, right?
Mhm. Right, right. And for a plane, there will be a perpendicular line.
Okay, so yeah.
Yeah.
Why did it create that by itself? I just found the perpendicular vector.
Mm, you found the plane that is perpendicular to that vector. Yeah.
No. I found a vector that is perpendicular to the plane. So we looked at the plane as what we could reach with the scaled and scaling of the vector and the addition of the two vectors. And now
Right,
we wanted to find a perpendicular to it, right?
right, right.
So now that I see the plane,
Now we can scale that perpendicular to get a line, a complete line.
eh,
We have a whole line that is perpendicular to that plane.
yeah, I mean a whole line of vectors. Yeah, you're right. And that line has to pass through like 0,
0,
0,
0 and
0
that vector. Yeah,
W.
perfect. Bravo. Yeah, right.
So the vector also passes through 0, 0, 0, and the plane
Plane
also
also
passes through.
passes through 0, 0, 0.
Okay, all good. I think
Yeah,
this is what the question was talking about, right? So in the above set W, find all the points on X, Y, Z. So what we did was we kind of found one point which is represented by this vector,
right,
right? This vector -1, 2, 1, -1 is this vector over here. Yeah. And we realized that if I scale that vector, even if I take -2, 4, and -2, which is 2 times this vector, that still goes to 0,
right,
right? So every point on the line that 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 can be reached by that vector actually goes to 0, 0, 0, which is the origin.
right.
And this is nothing. Is it okay if I use jargon now, sir, or maybe you can go ahead and explain?
Sure. Tell me the word.
Yeah, I think this is the null space, right? Because null space is defined as all the points.
Yeah. Null space we will not use now because that's coming. That the entire thing is motivation for that. Just use the word dot product.
Yeah,
The dot product is 0 for these two. This vector and this vector W and any point on, I mean, any vector on this plane.
right. Will lead us to 0, 0, 0.
No, it will I mean the dot product will just give 0, right?
Yeah,
Yeah. Okay.
yeah.
So I think we should close also. I think it's
Right,
quite late.
right, right. So, guys, this was it. This was today's session, and
Thank you for
we'll meet
staying
you.
till the end,
Yeah.
Yeah, we'll meet you
everyone.
tomorrow, 9 o'clock.
Yes. Sure.
Thank you, guys.
Thank you, guys. Bye, guys. Thank you, sir.
Bye.
Thank you.